Good morning, students.
Morning, ma'am.
Good morning, ma'am.
Morning, ma'am.
Morning, ma'am.
Yeah, I hope screen is visible.
Yes, ma'am.
Okay. Okay, so in the previous class, I had asked to draw this diagram. Have everyone done it, and have you all named these parts?
Yes, ma'am.
Okay.
Yes.
Yeah. So this construction and working of glass electrode is going to be asked for 6 marks. Okay. So first let us see what is the construction of this glass electrode. So construction, it this electrode is made up of a glass tube. Okay, so this electrode, you can see it is made up of a glass tube with a bulb at the bottom. So with the bulb at the bottom, and it is made up of a special type of glass. So this bulb, it's made up of a special type of glass, that is the silicate glass. It's made up of a special type of glass, that is silicate glass, which is having high electrical conductance. So this bulb is made up of silicate with high electrical conductance, and this silicon dioxide which is present, that is silica, SiO2, it is doped with sodium oxide as well as calcium oxide. So the overall chemical composition of this glass membrane is approximately around 22% of Na2O, sodium oxide, Na2O, and then 6% of calcium oxide, CaO, and then 72% of SiO2, silicon dioxide. Okay, so the composition of this glass membrane is 22% of Na2O, CaO 6%, and 72% silicon dioxide. So this glass membrane is responsible for the exchange of the ions. As it is very sensitive to H plus ions of the acidic solution, this electrode is usually used for measuring the pH of the given experimental solution. So how this membrane is going to undergo the ion exchange reaction along with the solution that is containing H plus ions. So how it is going to become sensitive to the H plus ions, let us see now. So this glass membrane, as I said, it is found to be sensitive to the H plus ions of the acidic solution. So this membrane is going to undergo ion exchange reaction. That is, glass membrane can be represented as Na plus Gl minus. Na plus Gl minus. So this is glass membrane. And we have dipped it in the solution containing mixture of ions, wherein which it is sensitive to only H plus ions. How that happens? So this glass membrane will exchange its Na plus ion and take the H plus ions. So this glass membrane Gl minus will take the H plus ions and give its Na plus ions. So thereby glass membrane becomes sensitive to the H plus ions, and based on that it will help us to find the pH with respect to the H plus ionic solution in the acidic solution where we have a mixture of ions. Okay, so it undergoes ion exchange reaction. It will give its Na plus ion from the glass and take the H plus ions at the surface of this glass membrane by taking this H plus ions from the solution. Okay, so now how to represent this glass electrode? See here. So this construction part, in continuation to the construction part, so now you can see this bulb, right? So this bulb is filled with the solution of constant pH, that is 0.1 m HCl. As I have to determine H plus ion, I have to take the solution inside this bulb of known pH, and that too with the same ionic solution. So we are taking 0.1 m HCl solution. Suppose I want to determine some other ion. So at that time, I have to use that ionic solution in this glass bulb. If it is for pH determination, 0.1 m HCl will be added inside this glass bulb by the manufacturer. Suppose I want to determine cadmium ion from the solution. At that time, we have to take the electrode filled with cadmium ionic solution of fixed concentration. Suppose I want to determine lead, then lead ionic solution will be filled in this glass bulb. So based on the application, different electrode has to be chosen. So as we are focusing on pH, so we have taken 0.1 m HCl containing bulb solution electrode. Okay. And then in order to have an electrical contact from this 0.1 m HCl solution, we need some electrical contact. So for that, we have used an internal reference electrode, that is AgAgCl electrode. AgAgCl electrode, it is a secondary reference electrode. We know, right, there are two examples for secondary reference electrode. One is calomel electrode, another one is silver-silver chloride electrode. So this silver-silver chloride electrode is used for external electrical contact. So it is dipped in this 0.1 m HCl solution. So how this AgAgCl electrode is made? So I'll show you. So this is actually Ag wire. On that Ag wire, AgCl will be coated, and then this entire tube will be filled with the AgCl solution. Okay, so it will be actually a Ag wire in this glass tube, and on the Ag wire, AgCl will be coated, and then the rest of the part will be filled with the KCl solution. So this is AgAgCl electrode. So purpose of using AgAgCl electrode is to act as an internal reference electrode, and it is dipped in 0.1 m HCl solution to provide external electrical contact. So now the question is, how do I represent this glass electrode? So we have to start one by one in which it is in contact with. So first we have Ag wire, which is coated with AgCl, and then it is dipped in 0.1 m HCl, which is in contact with this glass. Okay, let me repeat again. We have Ag wire in contact with AgCl, dipped in this 0.1 m HCl solution, and further it is in contact with this glass. So this is how the glass electrode is represented. AgCl, 0.1 m HCl followed by glass. Okay, so I'll give time to write all these things. So let me first complete the explanation of this, then we'll go for writing part. So what is the principle for this glass electrode to work? So inside the bulb, it's filled with which solution? It's filled with which solution?
HCl solution.
So it's filled with 0.1 m HCl solution. Outside the bulb, it is in contact with which kind of solution?
HCl solution.
H plus ionic solution. But we don't know what is its concentration. Okay, so it's like unknown solution for us. But inside also it is filled with H plus ion containing solution. Outside also it is filled with H plus ion containing solution, but both are differing in their concentration. When both the solutions, when this glass membrane is in contact with the H plus solution inside as well as outside, but of different concentration, then there develops a potential at this boundary, which is called as boundary potential. Let me repeat. When the glass membrane is in contact with the two solutions, inside as well as outside, made up of H plus ions, but of different concentration. Then there develops a potential, and that potential is called as boundary potential, which is represented by EB. It is E1 minus E2. E1 is the potential associated with outer membrane. E2 is the potential associated with the inner membrane. So EB is equal to potential associated with outer membrane minus potential associated with inner membrane. So this potential is called as boundary potential. And it is happening due to what? Due to the different concentrations of the H plus ion solution inside the bulb and outside the bulb. Due to different concentration, potential is arised. That potential is called as boundary potential. Boundary potential is E1 minus E2. Is this point clear?
Yes, ma'am.
Okay. So same thing I have written here. Glass electrode works on the principle that when a glass membrane is in contact with two solutions containing H plus ions of different concentrations, there develops a potential. So this potential is called as boundary potential. And boundary potential is represented as what? E1 minus E2. So now let us start the derivation. How to start? So we know Nernst equation, right? So let us substitute Nernst equation once for E1 and once for E2. So once you substitute the Nernst equation as E naught plus 2.303 RT upon NF log of, what is the concentration for E1 here? That is outside C1.
E1.
Okay, huh. And for E2, it is represented as C2. Okay, so remember this. So once I'll substitute Nernst equation as E naught plus 2.303 RT upon NF log of C1 minus again in bracket 2.30 E naught plus 2.303 RT upon NF log of C2. And then E naught and E naught will get cancelled, right? Okay, and then 2.303 RT upon NF I can take as common, and then we remain with log of C1 upon C2. So this will be the simplified version. In detailed steps are not required in this. Okay, so this is how we get once you substitute Nernst equation for E1 with concentration C1, and once you substitute Nernst equation for E2 with concentration C2, this will be the simplified final form. So now, the potential of this glass electrode, it depends upon three factors. One is the boundary potential. You saw boundary potential is occurring due to the different concentration of the ionic solutions present inside as well as outside the bulb. So this is one potential. It is depending on. Another potential is potential of the internal reference electrode. So we have taken this AgAgCl electrode, right? So it will have its own potential. We cannot neglect that. We have to consider the potential with respect to this AgAgCl electrode also, which is represented as internal reference electrode, and that will be IRE, internal reference electrode, that is AgAgCl electrode. And then there is one more parameter on which it is dependent, that is asymmetric potential, EASY. So what is this asymmetric potential? See, I said you all that if the concentration of the H plus solution inside the bulb and outside the bulb is different, then the potential is going to get developed. Now, when the concentration of H plus ions inside the bulb and outside the bulb, if they are same on either side of the membrane, if the H plus ion concentration on either side of the membrane, inside as well as outside, if it is same, do you expect any potential to develop across the membrane? Okay, so theoretically, yes, theoretically we say that no potential should develop when the concentration across the membrane inside and outside remains same. It means actually potential should not be developed. But Practically, some potential is developed. Practically, some potential is developed even though the concentrations are same. So that is called as asymmetric potential. It's very minute potential that is formed, but we cannot neglect that also. So we are considering even that potential, which is called as asymmetric potential. So what is asymmetric potential? It is when the concentration of the H plus ions are same on either side of the membrane. Theoretically, no potential should be developed across the membrane. But practically, some potential is observed. So that potential is called as asymmetric potential. Okay, so now let us represent potential of glass electrode, that is Eg is equal to boundary potential Eb plus internal reference electrode potential EIRE plus asymmetric potential, that is EASY. Okay, so we are considering all three potentials. We are taking the sum of all three potentials now. So already we know the value of Eb. So it is 2.303 RT upon NF log of C1 upon C2. Substitute it here. Plus internal reference electrode potential, write as it is, plus asymmetric potential, write as it is. So among all these various things which are present, C2 is nothing but the solution which was taken inside, and its concentration is 0.1 mHCl, and it is having fixed pH. So it remains standard for us. Internal reference electrode potential, it is standard for us. Asymmetric electrode potential, it's also remaining as a standard. Means all these three values are going to become constants. C2, EIRE and asymmetric potential. So all these three constants, let us represent with a new term, that is Eg naught. So let us represent all these three constants with a new constant, that is Eg naught, which is called as standard reduction potential of glass electrode. So write down now Eg is equal to Eg naught plus 2.303 RT upon NF log of C1. Okay, you got to know, right? C2, EIRE and E asymmetric potential are replaced with a new term, that is Eg naught, as these three values are constants. So now Eg is equal to Eg naught plus at 298 Kelvin, we'll get it as 0.0591 upon N log of C1 is nothing but H plus ion concentration, right? So write that H plus ion concentration. And we all know that log of H plus concentration is nothing but minus pH, right? pH is equal to negative logarithm of H plus concentration. We all know that. So we'll substitute log of H plus concentration as minus pH, and number of electrons for this H plus ions will be 1 electron. So N will become 1 for H plus ions. So the final simplified version of this derivation at the last step will be Eg is equal to Eg naught minus 0.0591 into pH at 298 Kelvin. So this is the overall explanation of construction and working of glass electrode. Okay, so this is actually very important question. In case if Nernst equation derivation is not asked, then chances of this is very high during your exams. So I'll repeat. First you will write, then I'll repeat, or first I'll repeat and then you will write.
Will write
Right.
Okay. First you write off then. Okay. So once this slide is completed, let me know. I will change the slide. Okay. 1 second, I'll mute. Is it done?
No, ma'am.
Okay. Shall I change the slide? Anyone still writing?
Yes, ma'am.
Okay, once you are done, let me know. This is GL minus, okay? It may look like CL, it's GL.
In cell representation before 0.19, is it double slash or single slash?
It is all single slash. Because here we are not having any salt bridge. Until and unless it is connected with another electrode.
Yes, ma'am.
Okay, shall I change now?
Yes, ma'am.
Yes, ma'am.
Okay, so write down all these steps. So in this part, construction part I have not written in this slides, but it's there in the notes. Like I explained, right? It consists of a glass tube with a glass bulb at the bottom. These all parts, these all comes under the construction. So you have to write those sentences with respect to construction, and then you have to write that ion exchange reaction, and then you should explain like that the bulb is filled with so and so solution, it consists of AgAgCl electrode, all those things we have to write with respect to construction. And this boundary potential onwards, these all comes under the working part. Okay, write down, and once you are done, let me know. Yeah. Over. Anyone still writing? Done?
Yes, ma'am.
Yes, ma'am.
Okay. Fine. So who will tell me what is ion selective electrode? What is ion selective electrode? Tell you in your own words. Anyone?
And it is selective to a definite ion in the solution, like
Yes. Ion
sensitive.
selective. Yeah. Ion selective electrode is the electrode which is sensitive to only one particular type of ion from the mixture of various ions present in the solution. Okay. So why it becomes sensitive to only, or it will respond to only one particular type of ion? How it happens? Due to the presence of what?
The glass membrane in the electrode.
Yeah. So it is because of this glass bulb which is present at the bottom, which is made up of a special type of membrane, and that glass membrane is actually a silicate glass with high electrical conductance. And what is the composition of this glass membrane? Do you all remember?
Ma'am, SiO2 72% and
Hmm.
sod- sodium oxide and calcium oxide 22% and 6% respectively.
Exactly. Yes. Okay. So this glass electrode, let me explain the construction again. It's made up of a glass tube with a glass bulb at the bottom, and this glass bulb is made up of a silicate glass with a composition of 22% sodium oxide, 6% calcium oxide, and 72% of silicon dioxide. And this glass membrane is having high electrical conductance, and it is responsible for exchange of the ions from the glass. It will give its Na plus ion, and it will take the H plus ions. It exchanges the ions by undergoing the ion exchange reaction, thereby Na plus Gl minus, that is the glass membrane, it will give its Na plus ions and take the H plus ions from the solution. So that is how the ion exchange will take place, and this is how it is going to become sensitive to that particular ion. Okay, and this glass bulb is filled with the solution of constant pH. So here we have taken 0.1 m HCl, and it's represented as C2. And in order to have the electrical contact, that is external electrical contact, from this 0.1 m HCl, an internal reference electrode AgAgCl is being dipped. Okay, and then this entire electrode, when it is dipped in the experimental solution of the H plus ion, and that solution, let us represent it by C1. And now when the glass electrode, the glass membrane is in contact with the H plus ionic solution, but of different concentrations. Inside the bulb it's different concentration, outside the bulb it's having different concentration. During this condition, a potential is developed at the surface of the membrane. Okay, so that is called as, what is that called as? The potential that is
No idea.
developed, yeah, it's called as boundary potential. I'm audible, right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah, okay. So this glass electrode is going to work on the principle that when a glass membrane is in contact with two solutions containing the H plus ions but of different concentrations, thereby it develops a potential called as boundary potential. So boundary potential associated will be the difference of potential associated from outer membrane minus potential associated from inner membrane. So now we have to substitute Nernst equation, each of one for E1 and one for E2 with its respective concentration C1 and C2, and we will get the simplified version as 2.303 RT upon NF log of C1 upon C2. So now coming to the potential for this glass electrode. So it is going to depend upon three things. One is boundary potential, one is potential of the AgCl electrode, that is internal reference electrode, another one is asymmetric potential. So what is asymmetric potential? What is asymmetric potential?
And when the H plus concentration outside the membrane and inside the membrane are same, then a minute potential is supposed to be developed between them.
Yeah, actually, theoretically, when concentrations are same, it means, see here, our concentration, if it is same, if I cancel both of these, log of 1 becomes 0, right? So the entire potential has to become 0 actually. There should not be any potential developed. But practically, we do observe some potential. So that is called as asymmetric potential. So Eg will be sum of Eb plus EIRE plus asymmetric potential. Substitute the value of Eb here, and then now let us replace the constants with a new term. C2 is constant, this is constant, and this is constant. EIRE and asymmetric potential and C2. Let us replace them with a new constant, that is Eg naught. Eg naught is nothing but its standard reduction potential of glass electrode. So now C1 means H plus concentration. Log of H plus concentration means minus pH. At 298 Kelvin, we'll get 0.0591 upon N. And N plus N will be equal to 1 for H plus ions. Therefore, final form will be Eg is equal to Eg naught plus 0.0591 into pH at 298 Kelvin. So this is how we can find the electrode potential of Eg. Okay, so Eg naught, it will be given to us by the manufacturer of that particular electrode. It will be written on the electrode itself. Eg naught will be given by the manufacturer. And pH we can find just by using the pH meter. So dip the electrode in the solution of H plus ion solution, press the button to get the reading of pH, it will display the value of pH. So this is how we can find electrode potential of glass electrode. Any doubts in this? Is this
Is
understood?
there any experiment in the lab?
Sorry?
Is there any experiment based on this in the lab?
Yeah, we have. I'll be explaining this. We have a determination of pH using pH meter, and there we are using the same electrode, and we'll be given some acid solution. We'll be finding the pH values of that, and we will observe what is the end point of that reaction by titrating it against. It will be like acid-base reaction itself. So we'll be finding the end point of that reaction using this electrode by measuring the pH. I'll explain that very soon. Okay? Yeah. So now coming to the advantages of this electrode. So this electrode can be used to determine pH in the range of 0 to 9 accurately. So this electrode works best to find the pH in the range of 0 to 9. So, but if we want to get a higher range of pH also, at that time we have to select a very special type of glass, and then we can measure pH up to 12. And this glass electrode is also going to work even if the solutions are strong oxidizing agents. So this will work even in strong oxidizing agents. And the equilibrium and the end point can be reached quickly. And it's very simple to construct. And this is the most widely used electrode in determination of pH in various laboratories. Okay, and this electrode doesn't get poisoned. It will not get poisoned. So there are various advantages, like it works accurately in the range of 0 to 9. It can be used in the presence of strong oxidizing agents. Equilibrium can be reached very quickly, and it's very simple to operate and very simple to construct. And it's the most widely used electrode for pH determination in various kind of the laboratories, as well as this electrode does not get poisoned. Now, when there are advantages, definitely there should be some limitations also, right? So what are the limitations of this? So the glass membrane, the one which we saw at the bottom, that is a bulb kind of thing, it is actually very thin. Okay, it is actually very thin, and it offers high resistance. It offers high resistance. So normal or ordinary kind of potentiometers or pH meters cannot be used for this purpose. So we have to use high-end potentiometers or high-end pH meters. That is, the electronic ones have to be used. So this is one limitation. Another one is the electrode cannot be used to determine the pH above 12. Above 12, we cannot determine. Can you tell me what might be the reason? Above 12 means you can just logically apply. So what kind of ions may be present in that solution?
OH minus.
Actually, OH minus will be there. So it will be alkaline solution, but we'll be having some metal ions like sodium ions may be there, or lithium ions may be there. Okay, and H plus ions will be of low concentration. So 12 means obviously H plus concentration will be low, and these kind of alkali ions will be more. So these kind of alkali ions, they are going to interfere with our measurement, and they will form something called as alkaline error. So alkaline error will take place. Therefore, this electrode will not work above pH 12. So what are the two limitations? One is it's very thin, therefore it offers high resistance, and hence ordinary instruments like potentiometer or pH meters will not work. We need to go for the digital ones. Okay, high-end ones. Another one is it cannot be used above pH 12. The reason is because of the alkaline error. So these are the two limitations. Okay, so the instrument that we'll be using in our lab will be actually not a potentiometer, a pH meter itself. So in the same pH meter, we can measure EMF, that is potential value also. We can measure pH, that is pH values also. Just we'll be having two buttons there. So if I press potentiometer, if I want to measure EMF, I need to press EMF button. If I want to measure pH, I have to press the pH button. So this pH meter will work both for measuring EMF as well as pH. Okay, so how to determine pH using glass electrode? By connecting it to pH meter. I'll explain it tomorrow. So it's already 9:20. So can we draw this diagram now? We have 10 minutes. At least drawing part will get over.
Yes, ma'am.
Yeah. So this determination of pH using glass electrode is the application part. So we are going to find like how the pH can be determined for a particular experimental solution by using this ion selective electrode, that is glass electrode. So write down this diagram so that in the next class I'll directly explain the measurement part, and then we'll go for the next concept. So this is actually calomel electrode, and this is the glass electrode. So glass electrode, we all know if we want to measure the potential of any other electrode, we have to couple it with the reference electrode. So the reference electrode used here is calomel electrode. So it is connected to pH meter. Glass electrode is also connected to pH meter. So why glass electrode is taken on the right hand side, why it is going to act as cathode, why calomel electrode is going to act as anode, and how we can find the pH of this solution. These all things I'll explain in the next class. So meanwhile, you can draw this diagram. So this will be asked for 3 to 4 marks. So if it is asked separately, it will be asked for 3 marks or 4 marks. If it is asked for 10 marks, then it will be like explain construction and working of glass electrode with the application for the pH determination of using this glass electrode. So that time it will become 10 marks, 6 marks for the previous concept which we studied, and 4 marks will be for this. Okay, so write down, draw it. Yeah, you can make out, right? So like I have just drawn this. In calomel electrode, bottom we'll be having Hg, then we'll be having Hg2Cl2, then we'll be having KCl solution. Okay, and inside this we'll be having 0.1 m HCl solution. This is AgAgCl electrode for external electrical contact, and this is platinum wire for external electrical contact. Okay, did you draw or still drawing? No response?
One more.
Hmm. So experimental solution can be any solution that will be acidic in nature. So this experimental solution can be fruit solution, it can be saliva solution, it can be citric acid solution, any solution that is acidic in nature. So like in laboratories and all, that is quality control laboratories and all, if they want to find for any kind of solutions, they'll use this kind of method. Even our drinking water, you can use the drinking water also to check what is its pH. So we all have ROs in our homes, right? So we can check what is the pH. Which is next class?
Maths.
Okay. Is this over now? Still doing?
Yes, ma'am.
Done, ma'am.
Okay.
Yeah.
Fine. Yeah. So in the next class, I'll explain this explanation part. Okay. Okay. Yesterday, all of you took the Viva, right?